So I record because sometimes people sit through class and they say, I really didn't get that particular idea, so they go onto YouTube and they review it. Sometimes people have to miss a class, and if they do, they have the notes, and then they go on and fill them in just like they were in class. No, on YouTube. But there's a link, and I'm going to explain all that in a minute. So anyway, welcome to Math 107. My name is Linda Kavanaugh, and you're welcome to call me Linda. I'll probably respond to almost anything, but as long as you know it's polite. But you don't have to call me Professor Kavanaugh or anything like that. Linda's fine. So the first order of business is I want to tell you a little bit about the 3 papers you have in front of you. Okay. The first paper is called Student Lecture Notes. Okay. Now, if you notice, this packet, if you look through it, has 3 classes of lecture notes because there's 3 days to this week. So you will probably get most of the time either a weekly packet or a packet. I probably would have had the whole packet done up to your first exam, but formatting was driving me crazy trying to squish them all together. So I got this week together. So you will always have notes like this for every class. And all of these notes will be projected up to the smartboard. And you just have to go along and fill in. Okay, that's all you have to do. And these are here for you, and the recordings, as Mason asked, are also there to help you if you need, like, let's say our first test is on February 21st and you forgot the stuff we did the first day, or you need a little review, you can always go back and pop into the video. So let me show you where you get those videos. There's actually a link on our Moodle site. So let's go to our Moodle site first. So our Moodle site, this is the Moodle site, and you have a little welcome, and you see here syllabus and other documents. Anytime there's a class announcement, this is where it goes, right in here. So it'd be really great if you could please stay on top of your CC email, because if I need to tell you something, or there's a snow day and I need to tell you what you're responsible for, please check your email. And I'll probably put it right in here in class announcement. So taking a peek at this a couple times a week is a great idea. This is where all your lecture notes up until the first test will go. So this packet is in this little folder right now. And then your next packet that I'll give you next week will also be in this folder. So you always will have access to anything that I pass out in class right here. Now notice the first button here says link to Math 107 Spring 2014 class videos. So after today, all you have to do is press on that link and it will take you to a playlist. And I have 2 Math 107 classes. So I will either put up both class videos. You'll see Math 107A, which is who you are, or Math 107B. So sometimes I'll put up both videos. Sometimes I'll just put one in. It won't matter because it's exactly the same material. Now you see these 2 things here, the links to self-review videos. Okay, if you look at your pink packet, this I'm going to explain to you. We start off in chapter P in our textbook. Chapter P stands for prerequisite chapter, which means the author of the book says these are the prerequisite skills you should have to be in Math 107. So some of this material, I will cover a little bit of P1 today, and then on Wednesday, I'm going to start right in with P5, I believe it is. I'll have to look at your schedule. Let's see, your schedule is here. We're going to start in with P6. And if you look at your schedule, which is on the back of your syllabus, that's this paper here. So next to the last page, here, grab this, okay? You see, that's your schedule for the entire semester, okay? So if you look at Wednesday's class, notice what it says in parentheses, P5 self-review. P5 is factoring. Now, I know you've all had factoring before, or else you wouldn't be in this class. So if you look at this pink packet, notice I made it pink so you could distinguish it. I have information about the 3 areas you have to self-review. In other words, you are responsible to go to the textbook, Read and practice problems from that area. Now, I put P5 first here because P5 is the first section you have to self-review for Wednesday. So is the homework for today's class won't actually be due until Friday for this week. But what I'd like you to do between now and Wednesday is to actually get into your textbook, which is either an e-textbook or a soft-covered 3-ring textbook, or if you really want to buy the hardcover, which you don't have to, some students do, you can buy that, and review P5 for Wednesday. Now, the other thing is, if you look in your lecture notes, go to class 2. Class 2 looks like this, the beginning of class 2. Okay? It says on the top, class 2, right? It's about the fourth page, third page in, third or fourth page in, 1, 2, 3, keep going. Okay, does everybody see a table with some problems on it? Those are factoring problems, okay? So in other words, if you look over these problems and you say, no problem, I can do these factoring problems, then you probably don't need to even do much self-review, okay? But this would be the expectation of what you would be expected to do on Wednesday in order to start the material below it called rational expressions and domains, okay? So that's your prerequisites self-review. So out of all the stuff that you have to self-review, I'd like you to start with P5 in factoring. Now, some of you might go, oh, factoring. I remember doing that in Math 096, but it's been a while. Just remember, there's plenty of help here. You have the studio before class. You have me. You have peer tutoring. You have lots of resources. And on top of that, you also have my math lab. All homework's going to be done in my math lab. So let's take a look at that. So my math lab, loading. Oops, I had it all loaded up. Oh, my math lab. All right, well, let me just get another link here to my math lab. Has anybody used my math lab before? Yeah? Okay, good. Now, I'm going to, so when you sign into my math lab, this is what it's going to look like. All you folks that came in after class started, please come up after class and let me know who you are so I can get your attendance for today, okay? All right, so you're going to sign in as a student. You're going to register, okay? And all you need to do is turn to the very last page of your syllabus, and there's a sheet that tells you all of the steps, okay? The most important thing you see there in terms of getting is number 3. You see how you have a course ID? It says Kavanaugh 73843. That's what you will use to identify, to tell the computer what course you're in, because I've got all your homework and stuff in there. But this is really a step-by-step process. So I'm going to sign in as me to kind of show you what you're going to see, okay? Chris here. And can you scoot over here, please? I'm going to get you your stuff, Chris, in a minute. Any extra materials around? Just take a minute here. Everybody's aware that class starts at 8:40, is that correct? 8:40 is when class starts? Okay, I just want to make sure everybody knew when class started. You have materials over there? Yep, okay. All right. Please make sure you come up and let me know your name before you leave. Okay, so you sign into my math lab, and I'm going to sign in as me. Everything is very straightforward if you follow the directions on the last page of your syllabus. But I just want to show you how everything works. So many passwords. It's amazing how you can keep track of them all. Okay, so this will be your class, Math 107, College Algebra, Spring 14. So when you log in, this is what you'll see as the first page. Now notice it says upcoming assignments. There's an orientation homework that's totally optional. Like if you just want to go in and it kind of teaches you how you use like different features of my math lab. So if you've never used it before, there's only like I think 11 or 12 questions here that just sort of teaches you some of the features. Now notice it says the homework for P5, which I've asked you to consider looking at for Wednesday. Look what the date is for the due date. It says February 21st. That's our first test. All of your homework for the self-review problems is not due until the first test, but it would behoove you, that's kind of a cool word, right, to do it as soon as possible, okay? Because it is review and it will be used. And I've told you on your self-review packet, right here, the pink one, I've sort of told you when it would be great for you to have your prerequisite stuff done for which class. So P5 is for class 2. And notice it says P4 you should do before class 7, and P2 and 3 should be done before class 8. Okay, so that just sort of gives you a ballpark for when, and you can start working on those a couple problems a day if you wanted. Okay, there's no hurry. You have lots of time to do it. But this is what you'll see in terms of your homework. You're going to click on homework, and you'll see here orientation optional. Here are your first 3 review sections, your self-review, and here are the dates on the side when it's due. So notice the way homework's going to work in this class is you'll come to class, you'll have homework that night. It's due the next class. Generally, it's due the next class. So if you do it all by the next class, you get 100% of that grade. Let's suppose it's a tough week, you've got a test in English or science or whatever, and you only do 80% of it by the next class. So let's say you have like 10 points left, right, to finish that. You have until February 21st, the date of our first test, to complete it with only a 20% penalty on the unfinished work. So if it was 10 points left and you did it all, you get up to 8. So you have leeway in terms of if you can't get an assignment completed, you have leeway until the next test for whatever section we're in, test 1, test 2, test 3, to finish it off. Okay, I used to have like a week or so for people to do, and I just felt like if people needed to complete it prior to that first test or second test, that was reasonable to me. You all have different lives and different class schedules and responsibilities outside of class, so I wanted to give you that leeway. So when I said generally do this, today's our class number 1. There's no way I'm going to ask you to have that done for Wednesday because many of you have to get your book on my math lab and do all that. So notice this homework's not due until Friday, okay? And then Wednesday's homework is also, was class 3. Class 3 is missing. Oh, that's interesting. Class 3 I'll put back in. I was playing around with this last night because I didn't want you to see anything past here, so I changed all the dates. So somehow I must have lost class 3, but I'll get it back. So class 2 and 3 are both going to be due next Monday. So I still give you 2 days to do Wednesday's homework, but Friday we're back to the schedule of the very next class. So essentially you have 3 assignments this week. 1's due Friday, 2 are due on Monday. So that gives you the weekend. Now, the next question that tends to come up is, how do I get my book for this class? Well, when you sign in for my math lab, you have a choice. You can get an e-textbook. And let's suppose you need financial aid to come in, or you need a check to come in from work, and you don't have money right now to buy a textbook. Guess what? You have 17 days from today. The clock starts today, 17 days from today. You can go into my math lab and you can have free access to all the materials and the e-textbook for 17 days. So if you're in a situation financially where you can't afford the book, you still have a little, like 2.5 weeks before you have to commit to a book. So you have 3 types of books. You have a soft cover bound book, which nobody seems to have, right? You have one? Great. Let me show folks what it looks like. And this seemed to be a very popular option last year. It's all right. So it comes in, it's got three holes, and it's just like the textbook. It's even in color, which is nice. Some people like to have a physical book to refer to. So this is one option. As I said, the hardcover is another, but I think that's like $196 or something. And again, depending on who you are and what your areas of interest are in terms of future studies, it depends on what kind of book you want. A lot of students opt out for the e-textbook. Okay, so thank you. What's your name? Summer? Okay, so the nice thing about my math lab, I wanted to point out a couple of things for you. Let's suppose we go into this first homework problem, and you see you have 15 questions. They're all worth the point. Do you see this little thing right here? That means it has a video. So if you're working on that homework problem and you either you can't get started, or you click it and it says, sorry, incorrect, you can click on that and there'll be a video showing you how to do a similar problem. Every one of these that don't have the video has a little thing that says similar problem, and even though it's not a live person telling you, it's a step-by-step explanation of how to do every single problem. Students really like that. So everything here you'll have a chance to get some extra help on. These three right here have a video. The others you just look at a similar problem. Yep, yep.
Which is, I find almost more helpful because it's usually very similar.
Yes, yep.
And that way you can figure it out. Okay, so that's what I do over here.
Right, so let's
do it the real problem.
Let's look on questions.
Because when you do similar problem, they give you a new one after they show you how to do the first one.
Right, so here's what Mason's talking about. So this is your second homework problem. It says put 9 in for x and find the value of that. So you type in the number here, and let's suppose I'm just going to throw in a number just so you can see what like I'm going to make up a number. 13, just to make a mistake, and it will say check answer. Sorry, that's not correct. To evaluate an algebraic expression, first up, so they give you instructions. But let's say after reading that, you still don't know what you did wrong. You click over here, you can view an example. And there's an example, and you just keep hitting continue, and it shows you step by step what to do. So it's really cool, okay? Lots of help. All right, so that's how you sort of work around. And this little pad over here is sort of like if you want to put a fraction in, you want to take a square root or some other root. This is the kind of thing that your orientation homework would help you learn how to use. Okay, so that's, yep, go ahead.
I also noticed that all of these assignments that I saw listed are due.
Yes.
That's shortly after this class.
Yeah, so it's best to get it done before class. Yeah. I just picked 11 a.m. Yeah, you have an hour after class to finish it off. I just picked a time. Okay, it was random. Okay, so one thing I want to point out for you is this thing right here, Learning Guide. If you're one of these students that enjoys having sort of, how am I doing? How can I prepare for my first quiz? Do I really know this material? This Learning Guide is available to you, and this is how it works. For every single section in your book, so here's today's section, P1. And these are the topics in P1. Algebraic expressions, which I'm leaving for you to read about. We're going to focus on mathematical models today. So algebraic expressions in real numbers, you can read about, okay? But what's really nice is it takes every single objective that's taught in that section, and it gives you, so it first sorts it out by every objective, how to evaluate an algebraic expression. It takes a problem, it shows it out, and then it gives you a chance to try one. So some students like printing this out and working through this, like either after they do homework or to help them study for a quiz, to see where they really get what they're supposed to know, or they say, geez, I don't remember what an intersection is. Maybe I should ask Linda or go to the studio or look it up in my book, okay? So this learning guide is totally for you. If it's useful to you, great. If you never want to look at it and do any of this, that's fine with me too. This was not available to my students last semester, but I did put it on this semester thinking that it might be helpful. Okay, so again, there's lots of help in here. There's lots of help at GCC. As I mentioned, studio, your classmates, peer tutoring. This is one thing that is not available to you at GCC. So take a minute and let's look at this.
What kind of math do you have that you need help with? I have takeaways. Oh, you gotta do the takeaways? Yeah. All right, what's the problem? You have to help me with my math. Okay. Tell me what the math is. Okay. 16. Yeah. Take away 8. What's what? You tell me how much do you think it is? I know 1. No. How old are you? I'm only 4. 4? Yeah. Yeah. What's another problem? That was a tough one. Here's one. 5 take away 5. 5 take away 5. And how much do you think that is? 5. Daddy, what are you doing?
Okay, so please don't call 911, but we're here to help you. Okay. All of our videos can be found on YouTube. And as I said, if you put Linda Kavanaugh in, you're going to get like the first 3 or 4 pictures that comes up is this blonde woman who's, I guess, a news reporter or something. If you just scroll down, one of these days I'll figure out how to get my picture in here. So we'll have class, you can see here, class video review on exponents. Now, exponents is one of the self-reviews in the prerequisite chapter. So what I did is I went back to my 096 class and I pulled out a video from my 096 class, and you have the notes that go along, the class notes in the pink. So if you look at the last couple of pages of the pink one, you'll see lecture notes on integer exponents, okay? So I have a class video that also just reviews exponent rules that is even more basic than this. This deals with like negative exponents mainly, the ones that you always hate and get confused. So I have some review videos on there that are not from our class. Okay, but if you feel like, oh, exponents, I always got them confused, let me go back and review them, there's something there for you to review. Okay, one of the things I've just started getting interested in the last year is mnemonic devices and how to remember things. So for the first couple of exponent rules, I have some clever little things that might help you remember, but I'll have to tell you that in secret. I can't put that on YouTube. I don't want to say it out loud. And so if that piques your interest, come and see me and I'll let you know. Okay, so that's pretty much how homework works, how the class works. Now, today you came in and everything was all laid out on your tables. Although I really believe in helping you, I won't help you that much, okay? So you have all the lecture notes you need for this week right now. But when you come in, you're going to see 2 sets of folders up here. On this side will be the blue folders for your class, and on this side will be red folders for my next class. So the first person in for a table will pick up the folder, and you will check off that you're here that day. And if you came in late, make sure you put your name somewhere in one of these blocks and check that you're here today. Okay, so that's the first thing you've got to make sure you do. So Eddie's signed this, but Colton and Alicia. Okay. Oh no, how many Alicias do I have? There are Alyssa and Alicia and Elena. Oh my. Okay. I'll try to get it. Oh, it's going to be a confusing semester. All right, so so the first thing someone says when they sign this, they say, does that mean I have to sit here all semester? No, you're free to practice a different table every day if you want, but just keep track on one folder of your attendance. That's all I ask, okay? All right, so I know that was a lot in like 25 minutes. Any questions on either my math lab, your lecture note packet, your self-review, anything right now that you can think of? Yeah? Sure.
Here it says that if you use semester, but in my bio class this year, last semester we used semester biology.
Yeah.
So would my login work for this?
Uh,
You said it was good for 2 years, right?
yeah, for that one. You mean your same username and all that? Probably. I don't know. You'll have to check it out and let me know. So if I have a student next semester and they ask me that, so I'll rely on the two of you to let me know that. I don't know. This is only my second semester using my math lab, so I don't know about all the ins and outs of how. I know how you get to it for our class, but I would think your username and password, Elena, would probably work. The difference is you just have to put in the course ID for this course. And probably what you'll see under your home page is you'll probably have your biology course and this course listed, as my guess. Any other questions? Yeah.
I was in an algebra class last semester.
Yeah.
I don't remember the exact number of it.
Yeah.
They all use the same.
Yeah.
Textbook, right?
Yeah. Okay. Now, syllabus. This thing. Take this thing out. Okay. All right. I think personally, I don't know about you, but one of the most boring things when I was a student was to have a teacher get up in front of the class on the first day and read the syllabus to me. You're all perfectly capable, you're college algebra students, of reading the syllabus. So, if you look at the end of your first class lecture notes, let's take a look at that. That's page right here, the very end, where it shows you your homework. It says homework class 1. And then you see 3 bullets. The third bullet says read the syllabus. Wow, what a novel idea. Read the syllabus, really? Yes, because I'm not going to go over it. Answer the following questions and turn them in at the beginning of class 4. Well, class 4 is next Monday. So between now and next Monday, you have to read the syllabus, answer these 3 questions, pop your name on the top, and then when you come in, put it in this folder. This is how I communicate with you. Everything you hand in to me goes in here. Everything I hand out to you, like when I grade your quizzes and your tests, everything goes right in here. This is like our class management system. Okay? Anything you want me to have goes in here. Anything I want you to have goes in here. Okay? So the only thing I want to do is just make sure you're all, the only thing I'm going to go over, I've already gone over textbooks. You are also required to have TI 83 plus or TI 84. If you use another graphing calculator, I can't tell you that I'll be able to figure it out for you. This is what I know. All right. I have rental forms. If you can't afford a graphing calculator, we do have a rental program here, and I have those located in my little box there I can give you afterwards. So basically, the only thing I want you to know, everything else you can read, is 2 things. One is who should be in this class. You should be in this class if you've taken math 096 or 106. It was 106 last year, 096 this year. And you're planning on a course of study that may require applied calculus or calculus. This is sort of like the gateway course. They call it a gateway course for people interested in sciences, engineering, mathematics, and technology fields. Okay? If for some reason you're just a straight liberal arts student and you really have no intentions of studying any of those fields, maybe you looked at your course of study and you realized, oh, well, don't I just do one algebra course after the other? There's also a course called Math 117, Problem Solving, which is another gateway course. It is considered a college level math class, so you get you can get your associate's degree by taking that class. And that's for liberal arts majors who have no intentions of going out into any field that requires applied calculus like our business administration transfer program, or what else? Environmental sciences sometimes, or you're not interested in taking the regular calculus sequence. So if you have any doubts as to whether you're in the right class, right after class, check in with me and I'll help you. Every semester, there's 1 or 2 students that somehow make it into 107 and they're like, wow, I don't really have to do this course. You mean I can do Math 117? I say, yeah, you don't really have to be here. So sometimes people switch out the first week. So if you have any doubt, just let me know. Otherwise, read this. The other thing you might find interesting as you go through this packet, this syllabus, is that you have 2 ways to be graded: test heavy or test light. I give you an option. It's totally up to you. Test heavy says none of your homework's ever going to count. You just do it on your own. It's not going to count towards your grade. So if you're one of those people who say, well, I really can't sort of follow deadlines and get my homework in when I'm supposed to, but I'll do it on my own and I'm really a good test taker, that's the option you want. Your other option is test light, where your homework counts for 1/5 of your grade. Okay? It's a pretty nice little way you can control 1/5 of your grade. It's totally up to you by just doing your homework. Okay? That's all I really want to say about the syllabus, because you'll read it and let me know if you have any questions, and you'll pass them in on Monday, and I'll address any questions you have then. So how's that? Everybody kind of okay? All right, so let's get going with today's lecture. So pull out your first page of your lecture notes. And here we go. I'm going to zip right through the syllabus. And again, you may want to pull this schedule out. Some people separate the schedule, and if you have like a notebook or whatever, you put it right in the front so you can see what we're doing every day. When your quizzes are, when your projects are. Okay, you're going to have 4 or 5 projects throughout the semester. So here's our very first. So today you see there are 3 topics covered in P1. We're going to focus on mathematical models. Okay, that's our focus today. How to evaluate an algebraic expression you could do after math introductory algebra. So I'm not going to focus on that. And real numbers I'll talk a little bit about depending on how much time we have. Okay, so to start us off, when we do this, Elena, I'm going to pick on you because you're the first name I remember. You want to start us off with number 1? Yep. Okay, so want to read us what that graph is all about there, Elena? Adjusted for inflation. All right, so here's a little bar graph. We could have easily made a little line graph by putting a little, I could have made a dot right in the middle of each of these, like that, and I could have just connected those, each of those points. I could have set these up as ordered pairs and connected those points with some kind of line graph. Yep, right? So notice what this graph does. And so anytime you ever create a graph for a project or any kind of, well, actually a lot of your projects will have graphs in them, but notice it has a title. You know what each axis is talking about. This says ending year in the school year. Okay, whatever that means. That's kind of weird, but I'll tell you what that means in a minute when we define the variable. Tuition and fees. Okay, so you have a good sense of what this graph is telling you. So what I want you to do is I want you to just spend a few minutes. I'm going to give you like 2 minutes. I want you to look over this bar graph and just write down any observations about the data that you notice, and write down 1 or 2 things and then compare them with your table mates, okay? And then you can just see what you come up with. So do it on your own and then we'll talk about it. So what observations did you come up with at your table? Anybody want to volunteer? Mason?
It looks pretty linear.
It looks pretty linear. So what does that mean?
It's going up at a constant rate.
So it looks pretty linear. is one comment. And we're going to be a little more explicit, but when I asked Mason what that means, he says it's going up at a constant rate. Well, is that constant? Is it really a constant rate as you go up? And some are saying no. It's not really a constant rate, because if you just compare these first 2 years, it was 34.87. There's a steady growth, right? But it's not constant, is it? Because if you compare just the first 2 years, that ratio, which we call the slope, would say this one, if you drew a line between those two right there, that line compared with this line, can you see that this has a steeper increase, right? So I understand, Mason. So what Mason's saying, though, is, and we'll be learning how to do this, if you wanted to create a model for this, one of the models that you might choose is to approximate this whole thing with one straight line like that. Now, the line that we pick might actually hit some of the points right on the nose, and some of the points may be overestimated with this line. Like if I was using this line to estimate the tuition for 2003, my answer would be a little over. Some of them might underestimate, like at the beginning here. So it's possible you could use a straight line as a model for this, okay? So, yep, it looks pretty linear. I agree with that. What else did you notice? What other kind of comments did you come up with? Someone else? Eddie? So, over a 10-year period, the cost of tuition has doubled, more than doubled? Okay. That's kind of scary, isn't it? Okay. So, I'm trying to think. So we're going to learn probably the last week of class, we're going to be looking at exponential growth and logarithms. And there's this little rule, if you've been in a business class before, you might know it. It's called the rule of 70. And that means if you're trying to figure out how long it will take something to double and you know the interest rate, then you go like this. Suppose you said, okay, I've got a loan out and it's a 7% interest rate. Or let's say you do this, or let's say better, you have money that you're investing and you can invest it at 7%. Woohoo, that'd be great. Then that means it would take 10 years for that to double. This is a rule of thumb. So we can also reverse that. So what Eddie just noticed is if we use this rule of 70 and we say we divide it by 10, which is how long it's taken for this tuition to double, that means your tuition is growing on the average of 7% per year. Yeah. And actually, that's a little high for public schools. On average, it's growing 6% in the 4-year schools. So yeah, that's the kind of information you should start to be able to, when you look at a graph, think about for this class, because modeling is where we're going to be spending a lot of time. And let's go right to the model. I'm going to just talk to you more about this little symbol right there. That little symbol can be found right here on your y-axis or your vertical axis. And that symbol should be used anytime you begin a scale on one of your axes that is not at 0. Okay? And the only reason they don't have it here is look at this kind of, we thought that they made a mistake when they wrote that. Ending year in the school year. So what would be the ending year in the school year 2000? What would be the ending year, the last year there? Oh, right on 2000. What's the last year you see there? How many years is 2000 from 2000? 0. See, that's your last ending year. How many, what's the ending year on 2001? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why they have this kind of weird label on that axis, because what they're really looking at is how many years from 2000. They're using 2000 as their initial year to begin all of their data collection. That's why you don't see one of those little break in the axes right there. Okay, so actually the model that they chose to describe this data was not a linear model, but it was a quadratic model. So this is the model that they're using. So in other words, they said, even though a linear model might be a good way to estimate or predict, they're actually saying that you could probably fit some type, oops, that's not what I wanted. I just wanted a different color. They're probably, oh, now I've moved the whole thing. Let's see if I can get it back. Yep. So now they're saying you can probably more accurately, oops, oh, I can never draw quadratics very good. Now that doesn't look very good, does it? All right, I'm going to try it, but it's kind of hard with a mouse to do this. So let's see. Oh, I still can't do it. But you get the idea that there's a quadratic that you can fit through there. This is the equation for that quadratic. This is what we call a model. Now notice, this estimates the tuition for each year. And how are we going to put the years into our model? X represents the years after 2000. So if you go back to your graph, instead of putting in 2000 comma and then what's the first tuition, 3362, instead of plotting that, you would plot 0 comma 3362. Okay, and instead of plotting 2001 and then the next thing, it would be 1 what, 33487. So X, the value of X represents the number of years after 2000. So if we wanted to use our model to find the average cost of tuition and fees in the year 2010, what would be the actual value of X here? X would be equal to 10. And the way you get that is you say 2010 take away 2000 is 10. So now to estimate, that's the key here. We actually know the real value in 2010, but this model is going to estimate it. So to find the value of tuition in 2010, and if you wanted to, you could go like that. You could put a little subscript on it so you know that you're looking at the year 2010. Okay, you go 4 times X is 10, you square that, plus 341 times 10, plus 3,194. So the tuition in 2010, so see, I'm actually doing, by what we just did on the right side, we're evaluating the expression on the right side. So we are kind of covering that. 4 times 100 plus 3410 plus 3194. That's 400 plus 3410 plus 3194. So you add that up. What is it? 7,004. Now, if you compare that to the actual value on the graph, the actual value is 7,020. That's the real cost. This is our estimate. So did we underestimate the real cost or overestimate? We underestimated it, right? So we underestimated it by what, $16, right? So not too bad, right? When you're dealing with thousands of dollars, that's a pretty close fit to that actual data, right? So this is the type of question you might be asked in section P1. Now, this is where you got to be a little careful. Now we're going outside our data set, folks. Our data set goes from 2000 to 2010. That model is using that data. Anytime you go before 2000 and make a prediction or outside of your data set, that's called extrapolation, okay? Anytime you go outside the data set, outside your actual data set, you're doing something called extrapolation. Notice the problem we just did with the year 2010 actually was the year that we collected data for. This was called interpolation, inter, extra. So that was actually using one of the years that we had data values for. Anytime you go outside, you got to be really careful because you'll see why in a minute. Well, maybe. So at your seats, I want you to figure out using this model what you get for 2014. Okay, I want tables 1, look at me, tables 1, 2, and 3 to do the year 2014, and I want tables 4 and 5 to do the years 2050. Okay? You look at 2010, and what was the actual tuition, average tuition in 2010? 7,020, right? So they're saying 4 years later, about 8,700. Seems reasonable, maybe a little stiff, but then you look out to 2050 and you see 30,000. Geez, yeah. So one of the things you got to be careful about is, first of all, does that seem reasonable? Well, it's really hard for us in 2014 to know if that's a reasonable value. We don't have enough information. We don't know what's going to happen to the economy between now and then. However, sometimes when you look at a data set and you go out, like I just asked you to, you extrapolate, you say, no way is that a reasonable prediction. There's no way that's going to happen. Or if I asked you to go into the past and make a prediction, you say, no way tuition was that cheap or that expensive, depending on the situation. So this is what I want you to kind of put some stars around, because this is an important idea. Sometimes a model, if extended too far beyond your data set, can lead to estimates or predictions. It's really predictions when you go outside that make no sense. Sometimes they make absolutely no sense, or they're unreasonable. This is what we refer to as model breakdown. So that might be your first vocabulary word for the day that or maybe extrapolation was new for you, that you should sort of underline, and you'll be using this sometimes when I ask you to make predictions, and you'll say, wait a minute, Kavanaugh, this is where the model breaks down. It doesn't work, okay? So that's a new term for many of you, and I just want you to have it at your fingertips. Okay, so now we're going to go into sets and set theory, and I think some of you, most of you probably have seen sets before in your life. Set is just a collection of stuff, okay? You are a set. You represent a collection of students that are members of Math 107 Section A. You are a set of students, okay? So when we create a set, there's a couple of things you need to know. See these little braces here? They're called braces. It's a grouping symbol. That always indicates a set. Don't use parentheses. Don't use a little block, a little staple type figure. You use these little like profiles here, braces. Anytime you use that, you can list the members of the set. So I happen to pick a set that was very short. It was the Three Stooges. And there we go. This is called the roster method, is when you list every element in the set. So it has to be a finite set in order to do that. And you separate each element with a comma. So what I'd like you to do now at your tables is to use the roster method to list the set of 7 dwarfs. Okay, well, we'll let the other 2 tables listen in. All right, first of all, after B equals, did you remember to start your set off with this notation? That's really critical. So before you start listing, you have to have your braces. So who wants to show off? Kenneth, you want to show off? All right, so go ahead. Wait a minute, wait. Happy, sleepy, sneezy, bashful. Yeah, one of the ones that doesn't end in a Y. Bashful, dopey, grumpy, and Doc, right? Okay? Doc. So notice we're saying this capital B is equal to that set. So if I was referring to capital B anywhere within the problem, I would be referring to those 7 individual dwarfs. Okay. And I know my Boston accent just came out. I can't help it. All right. All right, so there's going to be another type of notation. Some of you may be familiar with it, some of you may not. It's called set builder notation, and it's a descriptive way to write sets. Now we're going to be alternating throughout the semester between something called set builder notation an interval notation. We'll get to interval notation in a little bit. So set builder always starts with your braces, and whatever variable you're talking about sits right there. So this says that when you go to read it, you say the set of all numbers x, and then you put this line in, a vertical line, and that line is read such that. So the set of all numbers x such that. Now we're going to assume for this class that x is a real number. So every time you write that down, you assume x is a real number. You don't have to state on the right-hand side that x is a real number. And then if I said something like this, notice what goes to the right of that is either an equation, an inequality, or a fact. So this is an inequality. So what might this set look like? Well, this set you could not list like we just did the 7 dwarfs because it's all real numbers. So what number comes after 2? Well, it could be 2.00009111092, right? This, you can't say what the very next number is. Notice I didn't say integers, so it's not 2, 3, 4, 5. It's all real numbers. So it's impossible to list it. So that's why we use something like this to say all numbers that are greater than or equal to 2. So if you had a number line, you'd go to 2 and you'd put a little solid dot at 2, and then you'd say everything after that. That's my set. So this is how you would see it on a number line. This is how you would write it with set builder notation. Okay, any questions on that? All right, so here's the, I can't believe this. This idea to write in the lecture notes came to me, and I was thinking about union and intersection, and I said, I don't want to do the same old stuff that books do, which just gives number sets. I'm walking up a road on Prince Edward Island, and I said, I got to come up with something that maybe would interest my students, and I came up with the Beatles. Now, what's even more incredible is February 9th marks their 50th anniversary when they were on the Ed Sullivan Show. Now, you probably don't remember the Ed Sullivan Show because you're not that old. I remember I was in the 3rd grade. I remember sitting in front of a black and white TV set and watching. I got to stay up late to watch the Beatles. And I couldn't understand why all the girls in the audience were crying and screaming. Anyway, so this year, February 9th, if you watched the Grammys last night, there'll be a Beatles sort of like, I don't know, retrospective on CBS. Anyway, that's my little thing. So who wants to read this for me? I know you do, Tyler. Read number 8 for me.
Members of the 1961 rock band The Beatles have heard not the same fact four that arrived in the U.S. in 1964. Let A represent the members of the 1964 Beatles and let B represent the members of the 1964 group. We will use the roster method in the scale set.
All right. So if you've read the book Outlier by Malcolm Caldwell, he taught, what is it? Oh, Gladwell. Thank you, Joe. Gladwell, he talks about the Beatles' time that they spent in Berlin, Germany. And one of the keys of this book is it takes about 10,000 hours to master something. So if you haven't spent 10,000 hours yet doing college algebra, don't expect to be a master, right? So I think I've got about 10,000 hours in, but you've got a few years to catch up with me. So the set A is John Lennon, Paul McCartney, George Harrison. So far we recognize that. Stuart Sutcliffe and Pete Best. Some of you, what? Okay. And set B, the 4 that came to the United States were the first 3 along with Ringo. Okay. Probably Stuart and Pete Best probably regret the decision not to be in the Beatles the rest of their life. Okay, so the whole purpose of doing the Beatles is I want to talk to you about unions and intersections. Now imagine, and this is my little memory device going on here. Now imagine all members listed above are still alive, so we got to use our imaginations, and we're going to plan a reunion, underline union. List the members who would come to the reunion and label it as set C. So I'm going to start off with my braces. Who would I put in set C? Who would come to the reunion? The ones who have been there the whole time. You mean John? Excuse me? Do you mean? I said Still alive. Everybody imagine it's still alive, Mason. So John, Paul McCartney, John Harrison, Ringo Starr. Is that all you want to put in there, Summer?
Well, Ringo Starr wasn't there.
Well, let's see what it says. So this is why it's important. Right. All of them. So who else would I put in here, Summer? Stuart Sutcliffe and Pete Best, right? So did I list John and Paul and George twice? No. So when you're looking at a union, okay, you denote the union by looking at what the set has in common, you list them once, and then you include any other members of the Beatles. Okay, it's a reunion, they're all coming, but they only have to appear once. Okay, so later on, in your own words later on, I want you to represent, in your own words, what you think a union of two sets are. And here's how we denote it. Set A, union with set B. That little U stands for union. Okay. Now we're going to look at set D is going to be the set made up of members of both bands. So who are the members of both bands? Someone else other than Summer want to let me know? Someone else that hasn't had a chance to speak up today? Or else I'll call on you. I know your names. Kenneth? John, Paul, and George, right. Those were the original three, and they were also part of the Fab Four. So in your own words now, think about how you would describe an intersection. It's got to make sense to you. I can give you the official definition, but it's got to make sense to you. Notice this is the symbol we use right here, the upside down U for intersection of two sets. Okay. So that's on the Beatles. And let's move along here to the idea of absolute value, which you're probably familiar with, but maybe you're not as familiar with the definition of absolute value. So notice this definition has two pieces. There's like actually two equations here. If you busted this out, you would have these two equations. Okay. And to put them together, we use this little brace here to say, this is the definition. There's two conditions placed on this definition. This part over here is a piece, a condition that helps you to determine how to describe the absolute value. So if we had a little more time, I usually have you just sit at your seats, because some people look at this and they say, wait a minute, you're saying the absolute value of X is negative. That can't be. See, they see that little sign there and they say, I'm trying to reinvent math here and say the absolute value of X is negative. Is that what I'm saying? Looks like it's what I'm saying. I'm saying absolute value, this is how students read it, absolute value of X is negative X, so it must be negative. So what's wrong with that thinking? It's only negative. It's only negative X if what's less than 0? X. So before you even apply this negative in front of X, what can you tell me about X? X is negative. And then when I put that little dash, which is another way of saying that is opposite of, so what does negative X represent if the X that goes in, the number you replace X with, is negative? What kind of number is it? Positive, right. So if you look at this first condition, if you're 0 or positive, you look exactly the same, just like you went into here. If you're a negative number and you go in here, you don't come out looking exactly the same. You've had a little plastic surgery, right? The little plastic surgery is it made you be the opposite of how you went in. Okay? So we could fool around with genders and stuff like that, but we're not going to. All right. So here's a little exercise I'd like you to do. Sometimes, always, or never. Please answer each of the following statements, and you put always true, never true, or sometimes true. If you answer sometimes or never true, change the statement so it's always true or show a counterexample. So I'll give you a couple of minutes to work on that. Put up your flags when you all agree.